What we did with creating the program Go Solve Word Problems is we applied those 5 tenets and brought them to bear on this program. The way it works is for each of the 9 different mathematical situations like parts and total that we saw, it breaks the instruction down into a set of 3 phases. The first phase is the anchored instruction, and those are short animated videos, and we're going to take a look at one of those in a minute. After you view the anchored instruction video, and that can be done whole class, it can also be done with the children working independently on their own. The segments are short, they're like 30 seconds. After they watch the anchored instruction, they move into the guided practice. In the guided practice phase, what happens is students are presented with a problem. Initially, they're given the appropriate graphic organizer, but then they're stepped one step at a time through the word problem. At each step, they're given corrective feedback if for any reason they don't come up with the correct response. So we'll take a look at what that looks like. But the key here is that you actually go through the anchored instruction and guided practice loop 4 times for each mathematical situation. Each time you spiral and you get a little bit deeper and a little more complex. After the 4th iteration, you then go into adaptive practice. And in the adaptive practice section, the problems become more challenging or less challenging depending upon the student's performance. So that's why we call it adaptive practice. Now, throughout this entire process, we are assessing the student, and we'll take a look after we look at the program at how the program reports that information back to the teacher or the administrator. The research that I referred to earlier really pointed to the importance of continuous transference of these skills. So you do have to reinforce what's being learned in the program. Most of the research that I read, and I know there's much more, and I'm not the absolute expert, pointed to the correlation between success when the appropriate graphic organizer was chosen. You have to choose the right organizer. Right. One thing we'll see, and we'll see this when we get into the independent practice phase, is you're not given the correct organizer. You can turn hints on and off, and with the hint, the first hint is it shows you the appropriate graphic organizer. Secondly, actually, after you go through the 3 of the mathematical situations, you get mixed practice that can be any of those 3, and that continues as you move along. So you will actually start to see more and more different problem types which require you to go back to something you might have previously learned. Okay, so we'll jump out of here and go into the program. Okay, so I'm going to begin working on the program, and again, I mentioned it's adaptive, and each student can log on independently, so it's going to remember where I left off. Initially, I'm going to log on as a student who's completing sort of the 3rd cycle on parts and total, which is the first of the 9 mathematical situations. Okay, so we're going to log in as, okay. Now we're going to begin with the anchored instruction video. So I'm told what my assignment is. And you'll see here it has text captioning built in. There are a lot of different accommodations in this program for students who have any type of special need.
So, I think I understand parts and total problems, but I have a question. What happens when something has more than 2 parts?
So you can see how the complexity starts here.
The class has $50 to spend on pizza, drinks, and dessert for the class picnic. If they spend $30 on pizza and $15 on drinks, how much can the class spend on dessert?
In this problem, the class is spending money on 3 things: pizza, drinks, and dessert. So we'll give the organizer 3 parts.
I get it. So, the class has $50 to spend on the class picnic. That's the total. The amounts they spend on pizza, drinks, and dessert are the parts. The question asks, how much can the class spend on dessert? So we're trying to find one of the parts.
Exactly. So how would you solve this problem?
We know that the parts add together to make the total, so
is a
So you
two-part
can see,
problem,
when you
like
use
what we
this
saw in the
organizer,
example
you need
from
to
the
figure
Nate
out how many parts there are. There could be 2, 3, or even more. Sometimes you have to look closely to figure out the number of parts. Here's an example.
At lunch on Monday, the cafeteria sold 10 cartons of plain milk, 15 cartons of chocolate milk, and 12 cartons of orange juice. How many cartons of milk did the cafeteria sell?
So, how many parts?
That's easy. There are cartons of plain milk, chocolate milk, and orange juice. That makes 3 parts.
Not so fast. Before you decide how many parts there are, think carefully about the question. How many cartons of milk did the cafeteria sell?
Oh, I see. Our
They
total
get ya?
is number of cartons of milk they sold. So there are only 2 parts. Plain milk and chocolate milk, and not orange juice. You do have to look closely.
So, 10 cartons of plain milk plus 15 cartons of chocolate milk equals the total number of milk cartons sold.
That makes 25 cartons. The cafeteria sold 25 cartons of milk.
Exactly. You always need to read the question carefully and think about the total before you decide about the parts. Ready to try it yourself?
So if you can think about it, in the first segment, they're finding the total. Then they learn that the information could be asking for either part in total in the second segment. Now in the third, we're introducing the fact that there may be multiple parts.